What's going on, my dudes? This is Math Time with Mr. G, and today we're going to talk about chords of a circle. So a chord is a line that cuts across and does not intersect the middle, so it's not the diameter. When a chord goes across, it will make the circle become two parts: the minor arc, so the smaller portion, and then the major arc. What's cool about a chord is no matter where it crosses, there will be some diagonal that cuts through it. So it doesn't matter where in the circle we can create a diameter that cuts through it. That will make a right angle. Because that's a right angle, this is right angle, right angle, right angle. Which means that F to G is going to be the same distance from D to G. Which also means that if I have a circle and it cuts and I make a right angle and I cuts and makes a right angle, if this is 16 and this is 16, that means that these two rays that cut through, these line segments that cut through, are going to be equal as well. So since this is the same measure as this, we know that these two line segments are the same. So we can just set them equal to each other. Solve for x. So x is -3. And we could plug that back in if they wanted to know the exact length of the line. If I have two chords, though, that cut through and do not go through the diameter, another way to look at this circle is like this, with 3x. The major arc that is created by these two chords is going to be twice as big. So this is going to be 6x, this whole big thing out here. So when they split up into two, I need to add those together. So 2 times x plus 7x minus 1 is going to equal 3x. So then I would get 8x minus 1 is equal to 3x. Distribute in 16x minus 2 is equal to 3x. Subtract x from both sides, I get negative 13x. And then divide by negative 13 to both sides. So I get positive 2/13 is equal to x. I can plug that back in and find the actual degree that was right here. Other than that, be kind to one another, ask lots of questions, and think deeply.